In this tutorial, we will be reviewing the Spack installation of ALPS on supercomputer clusters, specifically the Virginia Tech Falcon cluster. The ALPS information page can be found in this top left corner, and the Virginia Tech Falcon cluster information page can be found at this link. In order to access Falcon, Virginia Tech requires that you are on their internet. If you are working on campus, this is not a problem. However, if you are trying to work off campus, you will need to connect through a Virginia Tech VPN. The steps and tutorials for that can be found at this link in the top left. To make sure that WSL can access the cluster through the VPN, we are going to run this command right here, which opens up a notepad which contains the configurations for WSL. We want to make sure that we have these network settings inside the notepad. From there, we're going to do File, Save, and we can go ahead and close this out and restart the command prompt. To actually connect to the Falcon cluster, we're going to open up WSL and run this SSH connection. This first part is going to be your Hokie PID, and the second part right here is going to be the shared login node to which you are logging into. For this, you can either use Falcon 1 or Falcon 2. It'll prompt you for your Virginia Tech password and send you a duo push. Once you have logged in, we are going to access your home directory using cd $home and create a new directory called ALPS and access that directory. And just to confirm that we are in the correct space, we're going to use pwd, and this is where your batch script is going to live. Now we are going to create the install script in a terminal editor using nano install. Which brings us to this. And we can go ahead and put in our batch script. The first line tells the system that the script should be running using the bash shell. The second line names the job, which will come up in the SQ. So if you head on over to the Falcon cluster webpage and scroll down for a little bit, you will see this link right here, which prompts you to this page where you see your projects and allocations. For this, I will be using this allocation right here, and if I click active, this will be the Slurm name that I need to put into the third line right here. The next line tells Falcon which set of nodes to use. Falcon has 4 partitions: T4, V100, A30, and 140S, which equate to different GPU types. For ALPS, we are going to use the T4 normal queue. Each one of these partitions has a default quality of service. And for ALPS, we are going to use the standard option, which is _base. The time 6 hours reserves 6 hours of wall time for the cluster. ALPS takes about 1 to 3 hours to install, so this gives it plenty of headroom. Then we have the N nodes, which means Spack is only running on one machine. And then we have the N tasks, which means Spack is running one process. And then we have the CPUs per task. So we're going to have 8 cores processed to compile ALPS in parallel. And then we're going to have the GPU usage set to 1. ALPS doesn't actually require the GPU. However, in order to submit the batch job, we need to set this to 1. And we have the O and the E, which are output and error files. So this is going to give each run its own log. Then we have module reset and module load. The module reset wipes out any inherited modules that might have loaded in from the login shell. The module load loads any recent compilers which we might need. From there, we're going to load into the home directory and create a new directory called Spack ALPS and load into it. Then from there, we're going to clone Spack from its GitHub repository. Then we're going to activate Spack in this shell session, find the required compilers, and install ALPS. And it's important that we do the caret boost at 1.89 because Spack has recently updated their boost version to 1.90. However, ALPS version 2.3.4 is not compatible with this version, so we have to force the install with boost version 1.89. To save this, we're going to hit Control-O and write in the name of the file down here. Press Enter to confirm. And then we're going to hit Control-X to exit. Now we want to go ahead and just verify everything's correct. So using this line up here, the cat install alps, we can make sure our batch script is correct in what we submitted. Then we can go ahead and do sbatch test only. This makes sure that Slurm will accept the request before actually queuing it. If that all looks good, we can submit the batch job using Spack install ALPS. There's a few ways to track the progress. The first is using CQ and your Hoki PID. This will show where your job is in the queue and what state it actually is in. You will either see a PD, a R, or nothing. PD means your job is still pending in the queue. Your R means it's running. And if you see nothing, then it is finished or there was an error. In the CQ, you will see a set of numbers, and that is your job ID. And with that job ID, you can use this line of code to actually tail the job once it is running and see what's downloading and what part of the process you're in. The main issue throughout this process in which failures can occur is that ALPS is not being installed using the correct boost version. Again, this is just because ALPS version 2.3.4 is not compatible with the latest boost version from Spack. And that is the Spack installation of ALPS on the Virginia Tech Falcon cluster.